Hello there and welcome to the online course Easy Geosteering. In this course, we break down the key aspects of geosteering into simple terms, presenting them in clear and organized way. We are currently in the second part of the course, BHA components, and in the previous video we covered gamma ray logging. And today we will continue with resistivity logging. Let's get started. So, the main function of resistivity is to detect fluid contacts and estimate saturation of the formation. Let's take a look at the sketch of resistivity tool. In certain design it has 5 transmitters and 2 receivers. How does it work? Transmitters and receivers are conductor coils with a few turns. One after another, each transmitter generates an electromagnetic signal which travels through the formation and experiences phase shift and amplitude attenuation. The tool measures the phase and amplitude at receiver 1 and receiver 2, calculates the difference between them, and then, using special charts and algorithms, transforms these values into formation resistivity. As we can see, phase is sensitive to measurements across the entire range up to 1000 ohms, while amplitude reflects changes up to approximately 50 ohms. Also, phase has better vertical resolution, while amplitude struggles to detect thin sublayers. However, amplitude has a deeper depth of investigation, which is why both measurements complement each other. How many resistivity curves can we have? The current tool has 5 transmitters which operate at 2 frequencies, 400 kHz and 2 MHz. Additionally, we have both amplitude and phase measurements. It means with this setup we can obtain a maximum of 20 resistivity curves with different depths of investigation. The shallowest is around 20 cm and the deepest is around 1 meter. However, due to limitations in telemetry speed, we cannot transmit all 20 curves in real time. That's why before drilling we usually select 3 curves that best describe the current geological cross-section and refer to them as relatively shallow, medium and deep. Okay, next, we also need to note one unique feature of this type of measurement – resistivity curve separation. There will be a dedicated video lesson on this topic, but the main idea is that resistivity curves might differ from each other due to varying depths of investigation and vertical resolution. Imagine we are drilling parallel to the contrast boundary between sandstone with 60 and shale with 10 ohms. T5 transmitter has the largest depth of investigation compared to the others. It will show a resistivity value lower than 60 ohms, since the conductive shale falls within its volume of investigation and affects its readings. Meanwhile, T4 transmitter will show the exact value of 60 because it has a lower depth of investigation and remains unaffected by the neighboring shale formation. As a result, on the log we will see 2 curves with different resistivity values. We can analyze the separation and try to get some useful information for us. For example, two-layer inversion is based on resistivity curve separation, and it allows us to detect the contrast boundary position regardless of the model and stratigraphic methods. Okay, we already know how gamma ray looks in typical terrigenous formations. Now let's take a look at the behavior of resistivity curves. Here we have 3 resistivity curves. Shallow is blue, middle is green, and deep is red. First, we know the reference values. Resistivity greater than 30 ohms suggests hydrocarbon saturation, while resistivity lower than 8 ohms indicates water. The first formation is shale. As we know, shale contains bound water, making it conductive and resulting in low resistivity, here approximately 15 ohms. Then we enter a sandstone filled with hydrocarbons which do not conduct electricity well, gas with 90 and oil with 50 ohms. Next, we encounter a water-saturated zone, causing the resistivity to drop to 5-6 ohms. And now we can see that resistivity curves can reveal fluid contacts, something that the gamma ray cannot. And the last part, sandstone with carbonate and coal sublayers. Again, they have the similar behavior, appearing as sharp spikes on the log. Actually, the resistivity of hard layers may not be very high depending on its carbonate content, while coal often has a much greater value, on the order of hundreds or even thousands of meters. However, using only gamma ray and resistivity, we still cannot definitely distinguish between them. Alright, we have covered resistivity logging. Hope you like this video. Remember, you can boost your practical skills with private lessons. Together, we will work in StarSteer to utilize all modern geosteering tools and drilling simulators, which immerse you into realistic geosteering scenarios. So stay tuned and give this video a thumbs up. In the next lesson, we will continue with neutron density logging. See you then. Bye-bye.